On this Ram 1500 with the 3.6 Pentastar, P0305 means the PCM is seeing a misfire pattern on cylinder 5. The truck may run rough, stumble under load, flash or turn on the MIL, and if stop/start is equipped it can be disabled while the fault is active. A cylinder-specific misfire can come from possible ignition, fuel, air, oil control, VVL, wiring, connector, or mechanical issues. So don't jump straight to a coil or plug until the fault is proven. The monitor only has a fair shot when the gate conditions are met. Fuel level above 12%, battery voltage above 10, 9 volts, ambient temperature above -23 degrees C, -9, 4 degrees F, coolant temperature at engine start above -7 degrees C, 19, 4 degrees F, or the engine temperature reaches 21 degrees C, 69, 8 degrees F, if it started below the threshold, and engine speed is between approximately 400 RPM and 6,200 RPM. The PCM sets this code when crankshaft speed variation between cylinders exceeds a calibrated value based on engine speed and load. Start with the basic system checks. Turn the ignition on, pull and record all stored information and keep the captured operating conditions. Then operate the vehicle under those same conditions and watch when the misfire shows up. While it is happening, watch the downstream O2 sensors. A reading that stays low points lean and a reading that stays high points rich. At the same time, use the misfire monitor to confirm cylinder 5 is the cylinder stacking up excessive misfires right now. If cylinder 5 is not misfiring during the test, treat it as an intermittent condition instead of forcing the rest of the chart. Next, look at the other recorded codes and any known bulletins. If there are active or pending codes tied to the fuel system, ignition components, air handling, VVL if equipped, or VVT, handle those applicable paths first. If nothing there redirects you, do the physical inspection. Look for belt wear, pulley misalignment or binding, sensor mounting concerns at the crank, cam, or MAP sensor, poor connector and terminal fit at related components, PCM power or ground corrosion, vacuum leaks, intake or exhaust restriction, internal engine problems, moisture on ignition parts, fuel supply or fuel quality concerns, and operating overload conditions. If you find a real problem here, repair that first and verify the repair before moving deeper. After the first inspection, check the engine oil level and condition. The oil side matters on this engine because oil pressure, wrong viscosity, dirty or contaminated oil, aeration, the wrong filter, low oil level, sludge, drainback issues, pump or pickup problems, and mechanical tolerance issues can all affect the way the engine runs. If an oiling or mechanical condition is present, repair it and verify the repair. If not, check the engine and intake manifold for vacuum leaks. Repair any leak and verify. If the intake is sealed, check fuel quality. Water in the fuel, wrong fuel type, old or contaminated fuel, low fuel and proper ethanol level. If the fuel is the problem, replace the fuel and if needed, flush and clean the fuel system before verification. If fuel quality checks out, move to the injector comparison. Release fuel pressure before working on fuel lines or fittings. This system can stay under pressure even with the engine off. Install fuel pressure decay tester 8978A to the fuel rail. Key on. Let pressure reach and stabilize, and record the starting pressure. Actuate the cylinder 5 injector while watching the gauge and record the ending pressure. After each injector actuation, start the engine to clear fuel from the cylinder so you do not risk engine damage. Then repeat the same test on several good cylinders, always starting at the same starting pressure. If the ending pressures are about the same, keep going. If cylinder 5 stands out, a small pressure drop points you toward debris in the fuel rail or injector, and a large pressure drop points toward a faulty or fouled injector. Repair what you find and verify the repair. If this engine is equipped with VVL, run the scan tool VVL system test before erasing the code and follow the on-screen routine. If the vehicle is not equipped with VVL, skip this portion and go to the spark test. If the VVL routine says the misfire is being caused by the VVL system, use the result to stay focused on cylinder 5. A rocker stuck low can show up as a high cylinder 5 misfire percentage, and one rocker stuck in low lift mode can cause a misfire at higher engine speeds, above approximately 4,000 RPM. For cylinder 5, the related checks center on the lash adjuster, rocker arm, lock pin, and plugged oil feed concerns. If the next step is actual oil pressure to the VVL solenoid, turn the ignition off. Remove the called-out VVL solenoid. Install kit. VVL adapters 2,027,300,090 in its place. Then start and idle the engine. Watch dual oil pump mode and let it run long enough to switch to low pump mode. Compare the cylinder head oil pressure reading to the main engine oil pressure reading. Cylinder head oil pressure should be within 5.0 psi of main engine oil pressure. If it is, inspect the VVL solenoid screen for debris and the seals for damage or incorrect installation. If the screen is clear and the seals are good, replace the VVL solenoid and verify. If cylinder head oil pressure is not within that range, diagnose and repair the lack of oil pressure to the VVL solenoid. Then verify. Now move into the ignition and mechanical side. Turn the ignition off. Remove the fuel pressure tester and reconnect the fuel lines before continuing. Remove the cylinder 5 ignition coil, reconnect the coil harness connector, disconnect the cylinder 5 fuel injector connector, install a spark tester on the coil and crank the engine. If you have a crisp blue spark, inspect the spark plug and the cylinder. Look for cracks, carbon tracking, oil, coolant, excess fuel fouling, gap out of specification, or a loose or broken electrode. If those plug conditions are present, replace the spark plug. If oil or coolant is in the cylinder or on the plug, diagnose and repair the cause before verification. If the plug and cylinder inspection look clean, run a compression test on several cylinders and compare known good cylinders against cylinder 5. If cylinder 5 compression is not within specification, use a leak down test to decide whether the cause is in the valvetrain or combustion chamber. Repair as needed and verify. If compression is within specification, swap the cylinder 5 spark plug with a known good cylinder, or replace the plug if access makes swapping impractical. Start the engine and watch the misfire monitor. If the misfire moves with the plug or goes away after the plug was replaced, the plug was the issue. If the misfire stays on cylinder 5, clean carbon from the valvetrain and combustion chambers using MOPR combustion cleaner. Clear the cleaner from the engine by driving, erase the code, and retest under the captured conditions. If the misfire does not return, the carbon cleaning repaired the fault. If it returns, visually inspect the camshaft, rocker arms, and springs for excessive wear or broken parts. Repair any issue found there and verify. If nothing is found, continue to the final connector and control checks. If the earlier spark test did not show a crisp blue spark, check the coil feed and control circuits. Keep clear of the fan, belts, pulleys, and loose clothing anytime the engine is operating or cranking. With the ignition off, disconnect the ignition coil connector. Turn the ignition on, command the ASD relay with the scan tool, and use a 12-volt test light connected to ground to probe the ASD relay output circuit at the coil connector. If the light does not illuminate brightly, stop the scan tool actuation and repair the open or short to ground between the PDC and the ignition coil connector, then verify. If the feed is good, use a 12-volt test light connected to a 12-volt source and back probe the coil control circuit at the ignition coil connector. Crank the engine for 5 seconds and watch the light. If it blinks brightly, replace the ignition coil and verify. If the light stays on constantly, check the coil control circuit for a short to ground. Turn the ignition off, disconnect PCMC2, and use the GPEC Diagnostic 10436 adapter on the engine harness side. Do not probe the PCM harness connectors directly because that can damage the terminals. If there is continuity between ground and the coil control circuit, repair the short to ground and verify. If the light stayed off constantly during the crank test, measure resistance in the coil control circuit between the ignition coil connector and the GPEC adapter. If resistance is below 3.0 ohms, continue. If it is not below 3.0 ohms, repair the open or high resistance and verify. If the path has led this far, slow down and go after connection integrity before condemning the controller. Disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Inspect connector seating, locks, corrosion, water intrusion, weather seals, bent terminals, overheated terminals from poor contact, push-back terminals, spread terminals, and terminal tension. Repair anything you find. Then reconnect everything fully. Make sure locks are engaged. Erase the code, and operate or test drive the truck under the conditions that run the monitor. If P0305 does not return, the wiring or poor connection issue is repaired. If P0305 does return after those connector checks and repairs, replace and program the PCM, then verify the repair. Keep verification separate from the testing path. Anytime a fault is repaired, clear the code, reproduce the operating conditions that originally set it, watch the Misfire monitor, and confirm the code stays gone. The main takeaway on P0305 is to prove the cylinder 5 misfire first, then work in order. Context codes, basic inspection, oil and air, fuel quality and injector flow, VVL if equipped, spark, compression, carbon and valvetrain. Then coil control wiring and PCM connections. For more diagnostic training, visit stepdiagnostics.com.